Welcome back. In this second half of 2.6, we're going to move on and we're going to start talking about stretches and compressions. So, a vertical stretch, the x values all stay the same, but it multiplies all the y values by a factor greater than 1. Okay, and again, this happens when you have a number multiplying the x term that is greater than 1. When you have something smaller than 1, so like 1/2 or something like that, a decimal, you're talking about a vertical compression. So once again, all the x values are going to stay the same, but it reduces y values based on whatever that factor is. All right. So to kind of give you a first-hand example of how this works, we're going to go back and we're going to use our favorite quadratic. All right. Now we've already talked about this quadratic function. So, for example, we know the parent function, y goes x squared. We know what values, 1, -1, 1, -2, 4. We know what that parent function looks like, right? It looks just like that. Okay, so again, that's not really a surprise, but I do want to show you what happens when you have these compressions and stretches. All right, so here, when you have this compression, I'm going to take all my y values and I'm going to divide them all by 2. Okay, that is what a compression will do. It takes all of your y values and divides them in half. So notice it's a lot shallower, okay? It's not increasing as quickly as it was before. Now what about on the other side? Sorry, let me just copy down our parent function. What about when we have a stretch, a number bigger than 1? Again, that's going to affect my y values. So I'm going to get 8, 2, 0, 2, and 8. And now those are the new y values that I plot. So 0, 0, 1, 2, 2, 8. So now for the stretch, look at how quickly it's making it rise. So the way I equate this is think of this like silly putty or like Play-Doh, okay? When the number is bigger than 1, you're pulling it, you're stretching on it to make it longer and rise faster. When you have compression or a number smaller than 1, you're squishing it down, you're making it shorter. Okay, so graphically, that's what's happening in all of these scenarios. Okay, but now let's look at what's happening with the equations. Okay, so here I have my parent function of that. Now I'm going to go piece by piece, and I'm going to write a new function based on those descriptions. Okay, so a vertical stretch of 2. Okay, so vertical stretch of 2, what that's going to look like is that's just going to put a 2 in front of that square root. Okay, now let's take a look at this. 2 or 7 to the left. Left and right is with the x, okay? And remember, it's opposite of what you'd expect. So left is going to be a plus 7 with my x. And then up or down is at the end. Oh, I'm sorry, not 7. That's a 2. Is at the end of the function. And it acts just like you'd expect it to. Going down by 2, you literally just put a -2 at the end. All right, let's try it with our x cubed function. So a compression of 1/3, that's going to put a 1/3 out front with my x. We're talking about a cubed function, so I have to make sure I keep that cubed there. Now I look 3 units to the right. Again, right or left, they go with the x. And oppositely, so right is going to be a negative in there, okay? That one always acts kind of oppositely of what you'd expect. Then finally, up or down acts at the end all on its own. And then, of course, you should be able to go backwards for me. So if I want to describe the transformations happening, well, you just have to read this left to right. So for example, this 3 here is my vertical stretch. Okay? Whatever is with my x is horizontal. My horizontal shift. And again, is opposite of what you'd expect. So because you see a negative in there, that means it's to the right. This +2 at the very end is your vertical shifting. And that acts just like you would expect it to. All right, so last example. The graph of y equals 4x is compressed vertically by a factor of 1/2 and then reflected over the y-axis. What is the new function rule? All right, so first, compressed by a factor of 1/2. So what is that going to do? That's going to multiply my function by 1/2. Okay? So that's going to give me the function y equals 2x. All right? So there's the first thing. Second thing, it says reflected over the y-axis. Well, for it to be reflected over the y-axis, that means my x is what takes the negative. That's going to give me the function y equals -2x, okay? So you can follow directions too as you're reading through them. You can apply them as you're reading them, okay, to get what a new function looks like. Now again, just to highlight the important details here is if these make sense to you, if you're really, really good at those, you feel confident with those, you're going to be fantastic for this section. Okay, again, just to highlight the key things that I'm looking for. If you can do that, you're golden. Okay, so now, sorry for all the scrolling up and down, but now what I want you to do, take a moment, write that reflection. This is a rather short video, which I'm guessing you're going to be very pleased with, but just to make sure you still take the time, write that summary for me really quickly, and then come back ready to do your practice work.